Okay. So what we have discussed in the last classes, guys. So we have seen that how to configure the static router. Basically, first of all, we have seen that what is the need of the router, right? And then after that, we went through that what is the use case of router and the definition of the router, like where do you need a router? Okay. Then after that, we have seen that what is the routing, right? Then we have seen that what are the flavors of the routing we have. Basically, we have a static routing and dynamic routing we have. So I told you that we are going to cover the static route first, and then we'll jump to the dynamic routing. So in the static route, what we have seen that, like, in a static route, we have seen that we have three ways to configure the static route. The first way is we have IP route. Then you need to put the destination network, right? And then you need to put the subnet mask information. And then after that, you need to put the next hop information, right? So next hop always will be your neighbor IP address. Your neighbor or address always will be your next hop IP, right? It's depend on the flow. Depend on the flow, what happened, the next hop IP will be changeable, right? Then after that, we have seen another ways to configure the static route. It's called as a next hop plus exit interface, right? And the third ways that we have, that's called as a IP route plus destination network. Then we have a exit interface plus next hop. So this is the third way that you can configure the static route. So the first two ways we have seen that actually I have shown you how to configure the static route in the first two ways. We have the IP route, this one and this one. The third way is that I gave you the task. Have you guys done this part? Have you guys covered the third part? Anyone? No? No. Okay, so let me start with the third one, right? So what we can do that, we'll go with the third one. I'll explain you the major difference between the first, second, and third, right? So I cannot draw the same topology that we have did on the Cisco packet tracer, the day one of the routing. So what I can do that, instead of the PC, I'll take a loop back. So let me do it. I'll say the static route. And here we go. I already have it. I'll make a new lab. Static route with exit interface. Right? So I have few routers, 72.0. 3 is enough for me. Okay. And let me change the icon. And so we have changed symbol. All good. So we have a router now. And let me connect all this router. So router 1, router 2 we have, and router 3 we have. Okay. And let's put the link between router 1 and router 2. Right. And here another link between router 2 and router 3. So the subnet that I'm going to use, right, the IP address that I'm going to use between the router 1 and router 2. So of course, this guy should be the 12.1. The subnet, this should be the 10.1.12.0/24. 12.2. This should be the 23.2, and this should be the 10.1.23.0/24. And this will be the 23.3. So we have basically, you can see that this is the subnet we have between the router 1 and router 2, and router 2 and router 3, we have a 23. Behind the R3, I have some loopback, right? Behind the R3, I have some loopback. So each loopback, right? Each loopback treats like a separate broadcast domain. So each loopback treats like a separate broadcast domain. So you can assume that, what you can assume that. So this is 3.0.0. It's part of the VLAN number 30, right? Simple way. It's VLAN number 40 we have, and this is the VLAN number 50. Just for the understanding purpose. So you can assume that, okay, so we have a users behind this guy. We have a users behind this guy, and we have users behind this guy. So this guy is running with the 3.0.0.0/8 subnet. We have this user is a 4.0.0/8 subnet and a 5.0.0.0/8 subnet. So basically a look back is what? Let me tell you, look back like a physical interface, right? Like a physical interface we have. Apart from the physical interface means what? You have a hardware, right? Hardware means what? You have a cable. A cable means what? A physical layer, right? Same way, what happened? Apart from the physical interface, we have some logical interface as well. One of the logical interface, right? One of the logical interface is called as a loopback interface. One of the logical interface is called as a loopback interface. In networking, right? Days by days, you will see the multiple types of logical interface you have. For example, another type of logical interface is called as a tunnel. Tunnel is also called as a logical interface, right? When you go for the higher level, like a service provider level, then you will find the BBI interface, right? IRB interface. These are also called what? These are also called as a logical interface. Another one. Remember, we have seen the port channeling concept, right? The ether channel, right? The ether channel is also called what? In an ether channel, we give the PU port channel 1 number, port channel 2 number. This is called what? This is also called as a logical interface. SBI. Remember, we created the SBI switch virtual interface VLAN number 10, right? This is called also what? This is called also as a logical interface. So logical interface has a multiple types, like a physical interface. Remember, the physical interface, we have a fast Ethernet link, serial link, 10 gig link, 100 gig link, 500 gig link, 1 gig, 10 gig, right? These are what? These are the types of cable. Same thing, the logical, these are the physical types of cable. Same thing, logical interface have a one of the loopback tunnel, VBI, RRB, then we have a port channel, then we have a SBI, multiple types of logical interface we have in the networking. One of the logical interface is called as a loopback. Now, what is the important role of the loopback in the networking? See, try to understand, of course, if this loopback is a logical interface, right? If this loopback is the logical interface, your hardware can be down. Listen to me carefully. Your hardware, your router can be down. This cable can be down. Maybe some, because it's a hardware cable, right? Anything can happen with this hardware. Maybe the cable goes faulty, right? Maybe something happened on the hardware side. Maybe someone was like walking through the data center network, and by mistakenly his and her hand is touched with the cable, right? So due to that reason, what happened? This link get flagged. So anything could be happen with the hardware. But this logical interface, nothing will be happening with this logical interface because it's a virtual, like a VLAN. It is present on the router. It is present on the router, but you cannot touch him. You cannot touch her. It's pure logical interface. So if your link goes down, if this physical link goes down, if this physical link goes down, if this physical link goes down, still you can send the traffic to this loopback. If you have at least one path, if you have at least one path, still you can send the traffic to this loopback. So why we are creating the loopback on the router side in the production network, so that we can easily identify is the issue with the particular cable or the issue with the complete router. If your router goes faulty, take example, if your router goes down, if your router goes faulty, if your router goes down, then this loopback will be down. Until unless this loopback will be still up. If the network engineer go under the loopback and say that, hey, I like to shut down this loopback, then that's the other thing. But if your router is up, your loopback will be up. So if something will happen with this hardware cable, nothing gonna impact to the loopback interface. So what we are gonna do that, whatever the practicals now we are gonna do on the GNS3, I cannot show you the like a PCs and switch over there, right? Because it takes some time. And now you are comes in the word professional level. So try to do the analyze each and everything with the loopbacks. It helps you. Why it helps you? When you go to the production network, in the production network, you don't have a PCs over there like that. Okay, we don't have a topology like this way, right? You don't have a topology like this way. Switch we have, then we have a PCs over there, then we have PCs over there, then we have a switch over there, then we have PCs over there. Yeah, at the time of right? At the time of starting, when you configure, the network, then you will have this kind of topology, right? Because you're configuring the network, you are designing the network. But once you have done with the designing, right, 90% task is coming with the word troubleshoot. How are you going to troubleshoot? Are you going to ask to the engineer, hey, can you connect the PC over there just to verify that I want to check the end-to-end connectivity? No, you cannot say that. You cannot say that I just connect the one PC behind the router room one. I just want to verify is there in the end-to-end connectivity is there or not. No, you just need to create the loopback over there just for the testing purpose, and create the loopback over there just for the testing purpose, and you can ping from here to here. If the ping is working, awesome. It means that your LAN to LAN communication is working fine. Okay, so make a habitual of this thing. Okay, creating the loopbacks, right? What is the loopback? And create the loopback on every interface. Each loopback, it's treated like a separate broadcast domain. Remember one thing, it's a very, very important question. Loopback doesn't have a MAC address. This loopback doesn't have a MAC address. We don't have any MAC address on the loopback. And if you don't have any MAC address on this loopback interface, then what happened? Because the logical interface, logical means what? No MAC. Normally what happened? On a physical interface, we have a MAC address, right? This logical interface, we don't have a MAC address. And by default, this interface is up. Normally what happened when you configure the IP address on this particular interface, you need to say that, hey, I like to up this interface by showing the no shutdown command. Same thing on this particular interface, what happened? You just need to say the no shutdown command, just wake up this guy, because all these guys in the sleeping mode right now. All these guys are in sleeping mode. So you just need to wake up this guy. Hey, I'm the network engineer. I like to up you. You need to wake up this guy as well, like an alarm clock. But this loopback is like a concurrent, right? Not a concurrent, it's always up. So you don't need to put the no shutdown command over there. Third thing is that what? You will never ever see the loopback in the ARP table. You will never ever see you always see this interface in the ARP table, this interface in the ARP table, but you will never see the loopback in the ARP table. Reason? Because ARP contain what? MAC plus IP information. Do we have any MAC for the loopback? No, we don't have any MAC for the loopback. So we will not have any MAC address for this guy. So you will not have a loopback in the ARP table. Understood? So let's do the basic part. What I can do that right now. Let me check my putty size. What the putty size I have. Appearance 18 is fine, right? I'll check to 16. So already I have uploaded the one notepad file. Okay, that's for the static routing. And what I can do that, I'll create the new static routing notepad, and I will upload this notepad to you as well on the drive link. So this is the router 101. I'll say the config terminal interface 0/0 IP address. I'll say the 10.1.12. I already explained you how to configure the IP address. I have already explained you what is the meaning of each command. This first keyword IP itself gonna represent that it's for the IPv4. And I like to give the address on this particular interface. That's why I put the address keyword, right? And this is for the class A private IP address, right? I need to give the submit mask information. Once I put the no shutdown in the background, what happened? In the background, right? This interface will find the subnet for this guy. Once they will find the subnet for this guy, they will add this subnet into the routing table associated with the interface, right? And then I don't have any loop back on the router number one. Okay, let's make a one loop back on the router number one. I'll just make sure that we have an end-to-end security. And here I'm not going to put the no shutdown command over there because loopback is a logical interface. So we have a loopback number one over here, 1.0.0/8. Right? Same thing on the router number two now. I want to save this configuration light. Let's save this guy as the do WR or and WR. If you want to save the configuration in the global configuration mode, right? For example, you are in the config terminal mode. And if you want to save the configuration, you need to use the do keyword, remember? Then you have to say the do WR. And if you're in the privilege mode, then you have to use the WR keyword to just save the configuration. And again, this is all we are talking about the iOS perspective, guys. Again, we all are talking about the iOS perspective. As told you that Cisco has a different iOS. We have a iOS, we have a iOS XC, we have a iOS XR, we have a Nexus, right? Security has a different iOS. So we are talking about the iOS perspective because in the your CCNP enterprise, even the CCI enterprise, you only have a iOS. Yeah, in CCI enterprise, you have a basic info about the XC or just information about it, but nothing else. On data number 2, we have config terminal interface 0/0, 12 or 2/24, no shutdown. Okay, come on, interface 1/0. I have a 10 or 1 or 23 or 2/24, no shutdown. And then we have a do.what. I'm in the global configuration mode. You can also use the copy running config to the startup config. R3, we have interface. I'll just define the host name for this guy, R3. Interface 0/0 IP address will be 10.1.23.3/24 and interface loopback number 1. I'll say this guy's a 3.3.3.3. Interface loopback number 2 IP address will be 4.4.4.4.4 and interface loopback number 3 will be IP address will be 5.5.5.5.5. If you want to give the description, right? So in the production network, what happened? Each interface, not each interface, most of the time, just for the easy to, troubleshoot, people are used to give the description. So you can.
Please, your 4.4.4, it seems like it's star or star or star. So kindly check it first. So that one.
What is
Thank you.
photo? It's correct, right?
Yes. Yeah.
It's correct. Okay, so if you like to give the description for this guy, you can give the description. So I can say that, okay, this is for the VLAN number 10. Just for the
Yes, that's fine.
heck of it, right? Same thing, you cannot give the description for this guy. For the loopback number 2, you can say that, okay, I'd like to give the description for this guy. This is for the VLAN number 40. Again, this is you gonna do that, right? A network engineer. This is called as a good practice or good design. So let's see, normally when I'm gonna configure, see in networking, what happened in networking profile, what you will face that a guy who will design the network. That's called as a CCD, network architect, right? Who's gonna design the network. A guy who is gonna manage the network and troubleshoot the network is called as a tag team, right? A network engineer. A guy who is gonna see the all the logs masses called as a NOC team. And one of the guy that's called as all the look for the basic part like a hardware levels, like a physical cables, things, and putting the router and this thing. That's called as a what we call. I normally in a different country we call as a different name. So normally people call as a ISPs. So either you can call as an ISP, either you can call as an engineer, right? So field engineer we can call it. So the field engineer who has always deal with they don't have any good knowledge about the protocols like OSPF, DHCP, BGP in the hard level. They know the basic part, of course, but these guys have a good knowledge about the physical cables and those things. NOC team know about the like in the logs and SNMP. This guy has a complete troubleshoot knowledge, right? This guy know how to design the network. So once this guy has designed the network, now your role is coming. Now you need to do the troubleshoot. So how are you going to troubleshoot it? So this guy, the network architect, this is the guy who designed the network for you. Say that, hey, this loopback is for the VLAN number 30, this loopback is for the VLAN number 40, and this loopback is for the VLAN number 50. So that when you're going to troubleshoot it, it will become the easy for you. Understood? So now we have done the IP addressing configuration. Let me take a console. Oh, what happened? Oh, my device is not started yet. Okay, now let me start this guy. This part we have done, right? So I'm gonna show you this lab, the exit interface. Plus next up, then we'll go the deep dive of this each and every one, and which one is a recommendation to doing the production. Okay, router one I have. So what I can do that I'll copy and paste this configuration, router number one. Copy and so we have some issues, right? I'll put extra zeros. All done. Now we have router number two now. Router 2 doesn't have any loopback because it's like a transit router. Why I call this guy as a transit router? This call as a transit router, this call as a stub router. So, these are the terminology that you may face in the production. So why I call as a stub router? Because this is the last router. This is also last router. This is called a stub router. But this router 2 is going to receive the packet and forward the packet. That's why it's called as a transit router. It's going to receive the packet and forward the packet. That's called the transit router. That's why R2. But R3 is just going to receive it. That's it. R1 is just going to receive it. He doesn't have any other connectivity. Router number 2 now we have. So these are the terms. Just write it down in your notebook. It's very important terminology. It helps you when you go for the interview to explain somebody. So when you're stuck somewhere, just try to move the things from here to there, right? If you're stuck somewhere, right, then you can explain that way, right? You have this router. So for example, if the packet gets stuck over there, like take example, you are going to explain the ARP technology, right? So somebody will ask you, hey, could you please explain the ARP? So you were explaining the ARP and somewhere what happening, you forget that some concept for the maybe 2 second and 10 second, and you need to recap those things. What you can do that, just said, okay, when the router number one has sent the packet to the router number two, and the router number two is like a transit router. So transit router is basically that it's gonna just pass the traffic, and then you can come back to our technology. Yeah. All done. We have three loopbacks. First, I'll show you one thing, guys. If you say show IP interface brief, right? I haven't put the no shutdown command over there. Can you see that? I haven't put the no shutdown command. So all my loopback is up by default. How many loopbacks you can create on the router? You have a good range, man. So if you can put the command loopback, you have a very good range. This number of loopback you can create on the router side. But is it necessary to create all the loopbacks? No. If you're going to create the multiple loopbacks on the router, unnecessary, right? That will cause the high CPU utilization and high memory as well. So no need to create the extra loopbacks. If you're creating it, the CPU and memory always comes in the picture. So now another thing, if you see one thing, so ARP, if you put the command so ARP, what you can find that in my ARP table, right? In my ARP table, I can only see the physical information. I don't see the loopback information. Have you ever noticed that you guys are working in the production area? Have you ever noticed that why I'm not seeing the loopback over there? You will never show the loopback because loopback doesn't have a MAC address. If you put the command show interface 0/0, include BIA, the burn in MAC address, what you can find that I have a MAC address for this particular interface. But do I have a MAC address for the loopback? If you see the show interface, loopback number one, BIA, no, I don't have any MAC address. I just put the show interface loopback number one. What you can find that, hey, loopback one is up right now. I have an IP address configured, and the description that I give this guy the VLAN number 30. Do I have a MAC address for this guy in here? No. I don't have any MAC address for the loopback. But if you see the same detailed information about the 0/0, what you can find that I have a MAC address for this guy. Where is that? I have a MAC address for this guy, but I don't have a MAC address for the loopback number one. Now what I can do that I want to achieve the communication between this loopback one to this loopbacks. So let's do the routing. So configure the static route. in the third week. So the first 2 ways we have seen on the Monday, right? So as the IP route, let me down this guy, and here we go. I on the router number 1. So I can do the same configuration in the CLI as well, but I'm not doing that because I can share the notepad to you and you can refer the notepad in future if you want, right? So on router number, what I told you there about the static route, if you remember, in the static route, I told you that, you know, you're only gonna configure or you're only gonna call those route which is not present in your local routing table. Listen to me. You're only gonna call right now, you're present on the router number 1. You are only gonna call those route which is not present in your routing table. So if you check the router 1 right now, so IP route, right? What information I have? I know about this 1.0.0 slash. I explained that already. Look back. Not look back. L is for the local route. You will see in the newer iOS version, but not in the older one. Look, L means what? Local route means what? It's just gonna tell you what is the interface IP that you configure that for this guy. Local host route, you can call it. This local route is also known as a host route. So you can see that I know this router 1 know about the 1.0/8, which is the loopback number 1, and he knows about the 12.0/24, which is this guy. So if router 1 already know this 2%, then what I don't know? I have no idea about this person. I have no idea about this guy, and this guy. So on the router number 1, right, this 4 route I need to define. One is called as a IP route, 10.1.23.0/24, and next hop will be also 10.1.12.0. So next hop always will be your neighbor IP address. So if you're sitting on the router number 1, who will be the neighbor IP address? Of course, this guy. How about the router number IP route 3.0.0.0? Next hop will be, I need to use the exit plus next hop, right? Exit interface 12.2, IP route 10.1.12.2, IP route 5.0.0.0/8, or good 0/0 and 10.1.12.2. That's all right. That's all the router number 1. Router number 2, have a look. What router number 2 doesn't know? Router 2 doesn't have any idea about this guy and this 4 guys. Because router 2 already know about this person because it's a directly connected, and router 2 already know this person because it's a directly connected. Router 2 doesn't have an idea about the loopbacks. So on the router number 2, you need to say that IP route. If you want to go to the 1.0.0.0 network, this is the subnet mask information. What is the exit interface? Of course, if I'm on this side, this will be the exit interface and my neighbor will be next hop. On router number 3 now, router number 2 itself, towards the 3, this guy exit interface will now change 0/1, 1/0. Same way for this guy. Awesome. And same way for this guy as well. We are almost done. 23 or 3, right? How about the router 3 now? Router 3, we have IP route. Router 3 doesn't know which guy. Router 3 already know this person, So we just need to define this person and this person. IP route, I have a 10.1.12.0/24 and exit interface 0/0, and next will be 23.2. IP route 1.0.0.0 and exit interface 10.1.23.2. So on the router number 2, this will be my exit interface and this will be the next hop. All done. Now let's put this route in the routing table. Copy R1. All done. Okay. router number 2 now. All done. And router 3. Router 3, what I can do that? I'm just gonna enable the debug so that things will recap. Okay. Debug IP routing. How does the router maintain the routing table? So if you see right now, I just have a 2 routes in 4 routes in the routing table. One is a 3, one is 4, one is 5, and one is 23.0/24. I'm just gonna configure this guy, and already my debug is enabled. So if you see the source debugging, my routing is enabled. What I can do that, I'll just copy and paste. So okay, hold on, copy and paste. So now you can see that what happened in background. Once I put this command on the router side, they added this information in the routing table with the next hop 23.2, right? And they added the 1.0/8 next hop 23.2. So if you check the routing table right now, do show IP route, I have a next hop plus exit interface. I have a next hop plus exit interface over here. So now you can send the traffic. There is no issue in the sending the traffic. So if you go on router number 1 and if you see the show IP route, what I can do that, I can see that, hey, I do have a information 3, 4, 5. So if I want to send any traffic for this guy, I need to send the traffic to the 12.2 from which interface? 0/0. So when I say the ping from the router number 1, what 3.3.3.3.3.3, and if I'm not going to define the source, then what happened? The source will be your 12.1 will be the source, and destination will be what? 3.3.3.3. Guys, it's a very, very important. When you don't define the source, right? When you don't define the source, always your exit interface will become the source IP. Always remember one thing. Always your exit interface will become the source IP when you don't define the source, right? When I say the ping 3.3.3.3, if you see that, and I'm just going to capture this particular link, right? Just to show you that. Done. And remember me later, echo request. Can you see that? The source is what? 12.1. This guy. ICMP works on the layer 3 protocol. Protocol number, this is the protocol number 1. On a layer 2, we have a ARP 0, sorry, not ARP IP. This is the type filter that we have. That is just going to tell the data link that, hey, data link, listen to me. This packet belongs to what? This packet belongs to the IPv4. You need to send this packet to the IPv4, not to the VLANs, right? Not to the data link layer. You need to route this packet towards the network side. So we have a source is what? 10.12.1. That's a default one. If you don't define this guy. But when I say the ping 3.3.3.3.3, source will be 1.1.1.1. Try to understand. Right? What happened? My source will be now changed. 12.1 will be, sorry, not 12.1. The 1.1.1.1 will be the source IP, because now I manually see that, hey, the source will be 1.1.1 and destination will be what? 3.3.3.3. The source keyword I'm using over the SO. And now you can see the capture. The source is changed now. Understood? So that's the importance of the source and exit interface. All good, guys. Anybody has a question in the basic configuration, right? If you have, you can feel free to ask me. Otherwise, I can move to the deep dive on the stream one.
Sorry, just one thing. So from routing perspective, if you could summarize the purpose or define the whole loop back addressing from the routing perspective, just in one line summary, if you don't mind. Thank you.
I didn't understand your question. When I meant say what do you want me to explain about the loop back? What is loop back?
Yeah, from a routing perspective, like just the purpose so that I can summarize it for myself.
So loop back is basically a logical interface. It's treat like a separate broadcast domain. So normally what happened, your router, right? On a router, we have a physical interface. Understand the concept. They have all the physical interface. Take example, all the physical interface goes down, then what happens? What you will understand? Tell me.
It will be
Your loop back, all the interface goes down, all the physical interface. Then what you will understand? Your router goes down?
yes.
Okay. But is it possible that router goes down if all the physical interface goes down?
No, the router
Not
could
all the
be
time,
physically
not
up.
all the time, right?
Yeah.
So what happened? We on the router side, we create the loop back. So loop back is a logical interface. It's not associated with any kind of hardware.
Right.
Okay. So even if your physical goes down, what happened? You can easily identify, okay, let me check the loop back, if the loop back is up or not. Because if you see, if I'm going to shut down this interface, can you see that? If I'm going to say, let's go on the router number 2 right now, because router 2 has a 2 interface right now, I'll create the one loop back as well. Okay, let's loop back,
Okay.
I'll create this guy. And I'm not going to put the no shutdown command over there. So it will be automatically up. Okay, I did on the router number 1 itself, man. So if you go on the router number 2 and say the interface loop back number 1, I say the 2.2.2.2.2. So if you see that, my interface is up. Okay,
Right.
what I can do that now? My loopback 1 is up. Okay, that's 2.2.2.2.2 is up right now. I'll shut down both the physical interface. Can you see interface 0/0 shut down, interface 1/0 shut down. Now understand the concept. If I'm gonna send the packet, can I send the packet now from the router number 1?
No.
I cannot. I still have a route in my routing table. Understand the concept. I
Right.
still have a route in my routing table, but my link is down.
Right.
Okay, both the link is down from both the perspective. Even
Right.
if you see the show IP route on the router number 1, static, the static keyword is just going to show you the static route, whatever you have.
Right.
I have a routing in this table, right? Even if I'm going to ping the 10.1.2.2, my neighbor IP address from router number 1, I could not. From the R3 as well, do ping, I could not.
Right.
So what you will now understand? Your router goes down.
That's what it would look like, but
that's why it's look like. But what I can do, I'll simply go log into this router, like physically I have to log in this router. I just want to verify, hey, so IP interface brief. It was, hey man, all the interface hardware is down right now. All the cable has a faulty. Loopback is working fine.
right.
So I don't need to replace the complete router. You can easily, segregate the troubleshoot.
Okay.
And
so
this is the one case again.
Right.
Just a one case that that the CCNA label and NP label, right? If you go
Right.
to I label, CCI label, things are very different about the loopbacks.
Okay. So at this point, from whatever we have discussed, but we would still need some kind of connectivity, either locally, let's say via the console cable, or some other link, let's say R4 or something, for the loop back to be accessible, correct?
Yeah, you need to have it at anyhow. So that's why, one thing, always what is recommendation? So whatever you're gonna telnet or SSH, right? Whatever the VTY connection you are doing that, you all
Right.
to the loopback, not the physical interface.
Okay.
Understood? Not the physical. You're always gonna take example. Let me give them one more example. Understand? If I'm gonna make this guy, right? Take example, right now say the telnet. Okay, which IP? 10.1.12.2. Understand the concept.
Okay.
From R3, which I'm pinging right now, I'm making the telnet to this guy. So
Right.
right now is working fine. The router 3 can get the access of the router 2. But take
Okay.
example, what happened if this link goes down? It's a hardware, right? Could
Right.
happen anything. Hardware
Right.
पे क्या हो सकता है देखो hardware पे क्या can happen anything. Maybe interface has a error, right, because of the overrun. Like,
Right.
you know, this is a little bit high terminology, I know. Overrun, maybe the CRC error comes in the picture. Maybe the
Right.
your line cable is working not fine. Maybe the, you know, light is not working properly over there. Could be happen anything, any
Yeah.
malfunction,
Any interface level issue. Yeah.
any interface level. So now can I make a tenant to this guy? Can I take
Uh,
access from the router 3 to the router 2 now? No.
no.
No, because you
No.
cannot send the traffic.
Cannot. Yeah. Interface level. Yeah. Cannot.
Because interface is down.
Right.
So what better approach is that one? Better to tell to this guy, I can make a tenant to this guy, loop back.
Right. Loop back.
Understood? I just
Okay. Yeah.
have
But
a one side connectivity, any from any other route. I just need a one route to reach this particular
Mhm.
loop back.
But that would still need to be
Accessible from anywhere. That's the one
right.
access,
No,
one
what I'm
route.
saying is it would still need the route to be defined in the other routers, right? For example.
That's a mandatory part, dude.
Okay.
That's a
Not
mandatory.
just because there is like a physical router connectivity doesn't mean that it would automatically be able to reach. You
Of
still have the
course.
routing to be specified. Okay, got it. Thank you.
But yeah, this is a very important question in the interview. Like I'll tell you, which company recently one of my student gave the interview. So I haven't explained this part in the one of the class, right? And he went for the interview, and the scenario-based question was there. The guy gave the scenario-based. It was a very big company. I forgot the name of that. So he said that can you help me out why the loop back is not showing in the app table? Now, what will be your answer? See, if you are a CCNA person, right? And even if you are a CCNP person, forget the experience right now. I'm not care about the experience. Anyone can ask me why the loop back is not showing that. So what will be your answer? Your loop back is down, maybe, right?
Right.
But now you look back.
No MAC address.
No MAC address loop back. So why should I care about this guy? ARP is going to contain the MAC address information, right? Do we have a MAC? No. So why should I contain the loop back over there? So some kind of scenario-based questions are coming from the interview, right? A different label. So yesterday, one of my, let me pause the recording because I don't want to say. So we have done with this 3 modules, guys. Anyone has a questions, guys? I cannot take the name, but it is 18 people right now. Anyone has a questions in this one? How to define the command line? If you're not,
No, and thank you for taking time to summarize that route to the loop back address part. Thank you very much.
Most welcome. So now let's move forward. Now understand the concept. The first we have over there, right? Next stop. Let me understand over here. What I can do that right now in front of you. I'm gonna remove the command line. What I can do on the router number 1. On the router number 1, I'm gonna remove the command. What I did. Okay, better to do what I can do. I can. Let me show you the different loop back as well and briefly explain. Thanks, Mosa. And I can take another one, static route. I have a different lab. Okay. I think so. This one, maybe that I'm looking for. No, not this one. I have a beautiful lab. Otherwise, I have to create the static route. Static route default one lab. Okay, so this one. Yeah, that's one I'm looking for. So, of course, 2 router. 1 is a customer router. You can assume that this is the customer. Okay, come on. Customer we have, right? And another we have ISP. Simple, right? So ISP has a multiple routes behind this guy. Let me check whatever the IP configuration we have. I hope we must have IP contribution. And guys, please pay attention because I cannot recap this thing again and again. The reason I'll tell you, because it is a little big topic and lots of theory. Okay, hold on, take your time and understand the concept. Because if you understand this one, see the static dot that you have to do that, we have done with the static dot. Now you have to understand the concept, why these three things we have in the market right now, and which one is the recommendation. So IP interface brief. I don't have IP. So let's configure it on the router number 1. So I'll say that this guy's a lab number 2, this topology, lab 2. Config terminal in router 1. Interface 0/0 IP does B10.1.12.1. I don't have any loopback on the router number 1. That's fine. R2. Let me check. Do we have any loopback on the R2? If they don't have them, I need to get all the loopbacks. Okay, so R2, I don't have the loopback, so let me create it. All of them. Then not 1.12.2/24. No shutdown interface. Loopback number 1, of course. I don't have a new loopback, so also the 1.1.1/8. No need to put the no shutdown command there. Loopback is a logical interface. They don't have any MAC address because they are not associated with any kind of hardware. MAC address is what? It's a hardware, right? MAC address is a BIA interface. BIA, it's a hardware associated on the hardware. Loopback is a logical. So loopback doesn't have any MAC address. So if you don't have a MAC address, you will never see the loopback in the R table. So there's a mini use case of the loopback. When you go in the higher level now, I'll tell you the CCI level, you can go and CCI speed, you will see the amazing things of the loopback. All done, man. You may name the loopback. I just named the loopback. Loopback number 1, loopback number 2. Loopback. Oh, you want to say the description, Keras? Router number 2 now we have. Okay, and I'll go and change this guy. All done. Oh my goodness. Some years. Okay. Loopback 10, I cannot do that. The reason is that, okay, let me change this interface to 12.1. And this guy said the name is 12.2. Goes back into that. Okay, and let's see, change. You understood why I'm doing this thing? Because previously it was a 10 subnet over there and 10 subnet over also over there. A router cannot have a same subnet, right? On the other interface. So that's why I need to choose this guy. And here we go. And then no error. And router number 1 as well. And I really need to save this topology for the future reference. All good, right? Now I can do that. Okay, I know, I'll tell you one thing, guys. You will give me the answer, which one is the better, understand the concept. Okay, so I'll give the static dot now on the router 1. The 5 it out, right? I'll tell you. Till the 5.1, I'll give the through the exit interface, you know. Duplicate, I'll do one thing over here. So this is the static dot that I have in the routing table. So the 5 dot I will give through the exit interface, or maybe the next hop, I can call it. And the 5 dot I will give through the exit interface. Now you will understand the concept. On router 1, I have to give the 5 dot with the next hop. So 1.0.0. Next hop will be 12.2. IP root. IP root 2.0.0. Next stop will be 202 IP route. IP route. Come on. IP route. All done. Next stop is done. Exit interface. 6.0.0.0. 0/0 IP route 7.0. Now let me copy in this map. Not right. Everything. So this will be 8. This will be 9. This will be 10. All done. Let's copy and paste it on the Arduino one. Bingo. So do show IP route static. It will only show you the static routing table. So when you work for the troubleshoot, right, always try to filter out the routing table, because if you put the command do show IP route, whatever the route is present on this routing table, you will see everything. For example, BGP, OSPF, EIGRP, RIP, static, other sub routing, everything you can see that with this command. But when you troubleshoot this thing, always you have to filter out. So I said do show IP route static. I have 5 routes with next stop and 5 with the exit interface. Okay. Now I'll try to copy and paste it. Okay. And that's my topology. Okay. So that's our router number 1 we have. Now, first understand the flow. What is happening in the flow? Try to understand when the router number 1 is going to say that, hey, I need to forward the packet to whom? I need to forward the packet to the 1.1.1.1. What happened in that case? Take example, source will be anything, because anyways, the router will perform the destination lookup, and based on the destination, he will forward the packet to the next router. And that's called as a destination based routing. So I'll take a source will be anything, doesn't matter to me. Destination is what? 1.1.1.1. When this packet comes to router number 1, what router 1 will do that? Router 1 is going to look up the routing table. Router 1 is going to look up the routing table. Here is a guy over here, right? There's a gate 1, gate 2. It's like if you're familiar with the Delhi Rajiv Chowk, there's a multiple gates, right? So you will get confused from which gate you have to exit. Same behavior is happening over here. There's a multiple gate. When this packet comes to the router number 1, this packet I'm talking about, we have a destination 1.1. So I said, hey, do I know the 1.1.1? It's like the routing table. Hey, I know the 1.1.1.1 in my routing table. And according to my routing table, I need to forward the packet to whom? Guys, understand the concept. I have a route. I need to forward the packet to the home. This guy wants to go to this room number 2 we have. This is the room number 1. This guy wants to go to the room number 2, but he doesn't know which gate should I follow. Which gate should I follow? Same thing is happening. When this packet comes to the router number 1, router says that, hey, I know about the 1.1.1 in my routing table. I need to forward the packet to the 12.2, but which interface I have to use to go out? which interface I have to, because I can have a 0/1 as well. I can have 0/2 as well. I can have a 0/3 as well. Which interface should I use to go out? So the first lookup, guys, again, I'm repeating, I cannot recap the same thing. Please pay attention. The first lookup, right? The first lookup the router one is doing for the destination. The first lookup the router one is doing for the destination. Second lookup, what he is doing router. Second lookup he is doing router for the what? From which interface I need to follow the packet. So second lookup he is doing for the what? How do I get to the 12.2? How do I get to the 12.2? So the first lookup I did for the destination. Second lookup I'm looking for how do I get to the 12.2? So I said the show IP route to the 12.2 is what? 0/0 interface. So second lookup I'm doing for the what? Exit interface. So if router will receive a packet, if the router will receive the 1000 packet, how many times I have to perform the lookup? 2 times, matlab 2000 times. Okay, this mechanism is called as a recursive lookup. The first lookup I'm doing for what? Exiting destination. Second lookup I'm doing for what? Exit interface. This mechanism is called as a recursive. So whenever the router will do the multiple times of lookup, more than one time, simple logic, more than one times lookup is happening, that's called as a recursive lookup. 3 times, 4 times, 5 times recursive lookups. If the one times lookup is happening, there will be no recursive lookup. And that's why this is called what? In some new books, it's written like a, this is called the next hop concept, right? This is called recursive static route. I'll just be back in the 1 minute, guys. Yeah. Anybody has a questions in this one? No? Have a look. Do show IP root 1.0.0.0. Can you see this keyword recursive over there? And the second way that you can see that all the router, right? In this, the first problem, what happened? In the first problem, whenever the router will receive the traffic for this guy, I have to perform the lookup for this person and exit interface. Now, this was this scenario. Whenever the packet was going for the distance of 1.1, I have to do the lookup for this guy and this guy as well. Now understand, same source, x dot x dot x dot x dot x, distance in what? 6.6.6.6. Router will say that, hey, whenever I receive the packet for this guy, 6.6.6, I need to check my routing table. Okay, let's check the routing table. So lookup is happening for what? First lookup, destination. Do I know the destination? Yes. Where should I forward the packet? He's just telling you, hey, listen, you just need to forward the packet to the 0/0 interface. That's all. That's all. Am I doing the double lookup right now there? No. In this case, what happened? I have no idea, right, from which interface I need to forward the packet. In this, can you see that this guy doesn't know how to get to the room number 2. I have multiple gates. But if I put the one gate right now, I just say, hey, you just need to follow gate number 1. He can directly go to room number 2. That's because he has single gate right now. He just have a single gate. So that's a beauty part you have over here, guys. What? I have a exit interface over there. I can just forward the packet to this particular interface. Once I forward this packet to this particular interface, the packet comes to the router number 2. And router number 2 has a route for the 6.0.0.0. For this kind of route, what happened? I'm only doing the one kind of lookup. So now if you see that, do show same person, say YP7 for this guy. First of all, let me put this guy in the routing table right now in the paint file. Take this guy into the paint. And from here to here. Right? And please allow me some space. Come on. It's not coming. Yeah. Right? This one. And now if you see for this guy, so IP7, come on. Do you have any kind of recursive keyword over here? I don't have. How many times we are doing the lookup? Here I'm doing the lookup for the 2 times. 2 times lookup. Right? Here I'm doing the 1 time lookup. See the C. You tell me which one is better. Tell me which one is better.
The one-time lookup.
Sorry? Guys, which one?
Exit interface.
Top one, bottom one.
The first one.
First one,
Second one. F0/0.
this one, right? Because in this case, we are not good for the CPU. It's good for the CPU, man. Save the CPU.
Yeah, for the performance side, I think that the second one is good because it's doing it
So
only
instead of
one time.
lookup.
Right? Huh? Yes. Good. Good answer. Now let me show you the another problem. Then you will say that then your preference will be changed now. Okay. let me enable the debug ARP. Understand the concept. Let's ping whom. I haven't pinged yet. If you see the show ARP, I just my own information 12.1. That's all. This is the only information that I have right now. 12.1, that's the address and the MAC address of this interfaces. If you see the show interface 0/0, include BIA. I have seen MAC address. Right? Let's get the MAC address of the router number 2 as well. All done. Now let's do pinging. Also the ping, what? Wonder. What's my routing table saying that, guys? For this guy. Let me write on the routing table over here for you guys. See the 12.2. Now it's understand the concept. I know it's little lengthy, but I'm telling you, if you understand this concept, right, everything will be clear for you guys. I know it's not important according to the syllabus perspective, but it's very, very important, right, for you to crack the interview. Okay. Debug ARP, already I did it. So debugging, if you see, is enabled. When I say the ping, wonder, my of course, if I'm not gonna mention the source, my source will be what? 12.1 exit interface. Destination will be what? Okay, that's my IP information. How about the layer 2 information? What will be the layer 2 now? Okay, layer 2 will be C201, of course, MAC address, right? What will be the destination MAC? Do I have any MAC over there? See that? Do I know the MAC of wonder one right now? Maybe you have a question, hey, loopback doesn't have a MAC address. I know, but can you, what I told you that each loopback treats like a separate broadcast domain. So we have one broadcast domain over here. We have one broadcast domain, another broadcast domain, another. So it doesn't matter. Doesn't matter to me because I just want to follow the packet, right? I just need a MAC address of this person. I just need a MAC address of this person. So it doesn't matter to me. So when I say the ping wonder one, pay attention what happened in the background, right? Hit enter. If you see, I'm generating the ARP request for whom? So this packet will be go on the hold. Right, of course, after the 2 seconds, it will be dropped, right? That's a time one. We have discussed this thing. Then he will generate the ARP request packet. In this ARP request packet, what happened? The source IP will be what? Sorry, source MAC will be C201. Destination, of course, FFF. Source again C201. Destination, I really have no idea what the MAC address. Source IP will be what? 12.1. And destination IP is what? 12.2. Now, let me write on this thing. It's very important. When you configure static it out, with next hop, then router always generate ARP request for next hop IP. Always next hop IP. So in this case, I have generated this one next hop IP. So I cannot put all the debug over there, right? Just understand the concept. I'll put the over here ARP for the next hop. Okay. Now come back over here. Now I have R. I have R for the 2L02. Now tell me one thing. If you have a ARP entry, do I need to generate again? No, right? If you already have a ARP entry, do I need to generate again? No, I don't need to generate again, right? So if I'm gonna ping the 2.2.2.2.2, still a 2L02, right? So do I need to generate the ARP request in this case? No, I already have a ARP. No, you will not see the ARP over here. Can you see that ARP? No. If I'm gonna ping 3.3.3, do I need to generate the ARP request? No. If I'm gonna 4.4.4.4, no. Because all this guy, because all they have a next hop. And I already have a ARP entry for the next hop. So do I need to generate? No. So what do you understand? You only have a single ARP entry. You only have a single ARP entry for the next hop. Only single ARP entry you will have. I'll put it over there. So I don't have a space, but I can do that better because I want to make everything in the single piece so that you can understand. I'll just draw the ARP table manually over here. So what happened for next hop? I'll put this guy over here. So for all the guy, right? For all the route, we will have only one ARP table, which is 12.2. Map will be, I can copy it. That's only you have this entry. That's and in this case, normal ARP comes in the picture. But when you configure a static dot with exit interface, then data always generate the ARP request for destination IP. Always for the destination IP. Understand, destination IP means what? Now in the data one, this will be changed. So now instead of the 12.2, you will have what? If I'm gonna ping the 6.6.6, this will be over here. ARP is a layer 2 packet. This is the layer 3 boundary we have. Can they cross this layer 3 boundary? The ARP layer 2 packet? Never. That's we have understand that. That's we have seen that in the ARP concept. It will never cross the boundary. It comes over here. That's all the router 2 said, hey, listen, you are the layer 2, and you don't have a capability to go beyond that one. So when this guy is R1 saying, hey, I'm looking for the, I'm looking for the 6.6.6.6 MAC address. So what router 2 said that, hey, I cannot forward your packet because you're layer 2, and these are in a different broadcast domain. So what router 2 will do? Remember in your classroom, guys, what happened every classroom in your childhood, there's a guy is called as a proxy guy, right? Whose job is what? Whose job is to make a proxy. whose job is to make a proxy in the classroom if your friend is not present. For me, like I remember myself, there's one of my friend, right, who was always doing the proxy for me. So most of the time I have some work in my college time and they do the proxy for me. Every classroom has a proxy guy. Same thing what happened over here. When the router 1 is sending the packet to the router 2 for this guy MAC address 6.6.6.6, router 6 says, hey, I cannot send this layer 2 packet to this broadcast domain because you don't have ability. So on the behalf of 6.0, guys, please pay attention. On the behalf of 6.0.0.0, R2 will give the reply to the router number 1. And when he will give the reply to the router number 1, he will add this MAC address in the reply packet. So if you see, when I'm gonna ping 6.6.6.6.6, man, I'm gonna generate the ARP request for the destination. Can you see that? See the output of the previous. In the next hop, 12.2. In the exit interface, if I'm a ping 7.7.7, I can generate the ARP request because every time this guy has to be changed, because for each destination IP, I need to generate the ARP request. Each destination IP. So always your 20% packet will be dropped. Can you see that? The first packet will drop just because of the ARP resolution. Because here the proxy is present and the proxy is giving the reply. R2 is giving the reply on the behalf of this network. And when R2 is giving the reply, he's putting the own MAC address C202. So by default, the proxy ARP is enabled on this particular interface. By default, the proxy ARP is enabled on this particular interface on the 0/0. On this particular interface, the proxy ARP is enabled. Because of that reason, what happened? R2 is giving the reply to the router number 1. And on the behalf of what happened, he is giving the own MAC address. Can you see the reply packet? So when the router 2 is giving the reply, IP ARP to the SIP from 7.7.7. So what R1 is assuming that I'm getting the reply from the 7.7.7. But what's the MAC address over there? C202. This MAC address is home. This router 2 interface. But what R1 is assuming that I'm getting the reply from this guy. But what MAC address is present? The R2 interface. Why this guy is putting the own MAC address? Because of the proxy ARP behavior. If I'm upping the 8.8.8, again I need to generate the ARP because for each IP, right, I need to generate the ARP request in the exit interface. Drop. Distance of the guy, I have received the reply. R2 is giving the reply on the behalf of 8. It's putting the own MAC address, same MAC address. Can you see that? Again, picking the 9.9.9.9. I have to make a request for the 9.9.9. The site will be changed now. Because in the exit interface, you are going to generate the ARP request for the destination. In the next hop, you're going to generate the ARP request for the next hop only. See, receive, same MAC address. Pick the 10.10.10.10. And again, if I'm not picking the 9.9, I'm not going to generate that because of course I do have now, right? So I'm not going to generate it because I have now. If I'm going to pick the 10.10.10, again. So assume right now, if you have thousands of the IP, you will have thousands of the ARP entry. So it's depend on the IP. So what happened over here? Let me tell you. For all the route, you will have only one ARP table. And here the things are changed. For all the IP, not the route I'm saying that. For all the IP I'm saying, you will have individual ARP table. ARP entry for example, 6.6.6.6. I have all this guy. For the 7.7.7, I have this guy. For the 8.8.8, I have this guy. For the 9.9.9, I have this guy. I'm talking about the IP only, not the route. In a one route, you can have a multiple IP, guys. Please pay attention in this word. Small things are very important over here. Understand in this way. Take example, if you have 192.168.1.0/24. For all this route, you will have a single ARP entry. But for all this guy, how many IPs are there? 254 IPs, right? Not 250 or 253. For all the 253, you will have ARP entry. For all the 253, you have a ARP entry now. So now understand the concept. If you see the ARP table on the Rado side right now, what you can figure out on the Rado number 1. So ARP, can you see? Man. So now if I talk about the ARP perspective, then what happened? If I talk about the ARP perspective, save memory, save CPU. Of course, if I have a less table, I can save the memory and save the CPU, increase the bandwidth. Right? Over here, what happened? I don't have a space. I'll just write it over there, right? In the small 12, it's fine. So use table require lots of memory. Degrade Rado performance. Wastage of bandwidth, because every time you're gonna send the what? You're gonna send the ARP request. And ARP reply comes in the picture. So each ARP request and ARP reply comes in what? Some size of packet, right? You see, somewhere it doesn't have any ARP packet over there. It doesn't have. Of course, some bytes of packet will have in that, right? And fourth and biggest is what? It requires proxy ARP. It doesn't require proxy ARP. Now, previously you guys told me that this is better because it's doing the one-time lookup. This was bad because he was doing the 2 times of lookup. He was doing the 1 time of lookup. So he was good. Now, if I talk about according to our perspective, man, it only have a single table right now. It's amazing. It's amazing. But if I talk about this guy, it does have a multiple table. For each IPs, you have a table. Take a different color, man. That's not gonna looks good. I cannot do anything now. It's done. So let me go with that same color. One time lookup, man. Yes. So now tell me which one is better now.
One time.
It's still one time, but it's still required the huge band, huge R. Can you see the R perspective? Huge table degrade the Rado performance investors of band that require the proxy R. Okay, one time. Let me show you that. Okay. Okay. What I can do that on the Rado number 1 right now. I'm gonna remove the ARP table. How I can remove? I can remove the clear ARP caching. This command will remove the ARP table, but normally, it will work on the real router. GNS is not sometimes working. Oh man, my debug is still on. So let me check. Let's remove that. No. So what I can do that better to shut down and also down this. If I'm gonna flap it, they will clear the content completely. Now, sure, I don't have any entry. Perfect. Okay. Now, what I told you that proxy R must be mandatory for the exit interface. I'll disable the proxy R interface 0/0, no IP proxy R. Service provider, right? He's a service provider, he can do anything. Disable the service, there's now no proxy ARP is there. Proxy ARP is mandatory. Mandatory for what? Done. Now what happened? Go on the router number 1. What ping? What guy? 1.1.1. I can ping it because for this guy, he's gonna generate the ARP request for the what? For the, I'm not gonna enable the debug, it's gonna take some time. He's gonna generate the ARP request for the next hop. He will make a request for the next hop, he will get the reply. Fine. I can send the traffic. 2.2.2.2, no issue. 3.3.3, no issue. Because all they have a next hop. 4, no issue. 5, no issue. But 6, dude, proxy is not there. How can I send the traffic? You still have a route in my routing table, man. You still have a route in your routing table. Can you see that? Can't send the traffic. Ping 70707. My all, if you see the debug ARP, I'm sending a request packet, right? Ping 6.707 even. I'm sending a request packet, but I'm not getting the reply because the guy is not present. The proxy, if take example, if the proxy person is not present in the classroom, who will give the proxy? Who will put the proxy? No one, right? Same thing. If the proxy is not there, you cannot send the traffic. I'm sending the request packet, not getting the reply, sending the request, sending the request, sending the request. If you see the SOAR, it's incomplete right now. It will be removed, of course. This is the time after the 60-second, right? It will be removed after the 60-second. But I don't have it. Now tell me, which one is better? So what I can do that, take your time, man. I'm not done with the study dot. I have one more day I need. So take your time, watch the video, understand the concept. Okay. And then we'll come to the conclusion tomorrow, and then we'll see that which one is the better. Right?
Mr. Shah, can I make a request? Is it possible you can upload this video to the drive as soon as possible so that we can
Max to max,
revise it?
I need a 1 hour, max to max.
No, that's fine. That's fine. But sometime, before tomorrow, because of the
No,
time
no,
difference,
I'll do it right now. I'll do it by today because I have some work.
appreciate it.
The first
Thank you
one
very
now.
Yeah, no.
When I say the first one now,
This-
no, not first one. We'll see that the result will become tomorrow, right? Yeah.
No, that's fine because this one is a little. I will need some revision for this particular topic.
That's why,
So-
see, I'm again telling you guys, okay, it's not mandatory to understand all this concept. The concept that you have already discussed, right? The 3 ways to define the static dot, right? The one is a recursive lookup, another is not recursive lookup, save the CPU and not save the CPU. These things that we have discussed, our perspective, it's not, see, it's important if you go for the interview and it's make you unique, man, if you compare it with the other one.
Well, for me particularly, I mean, we are already discussing this. We are already
Right.
putting time at this, so might as well make sure that we understand it thoroughly. You're putting time and effort, right? And and it is there. The material is there, so might as well, go through it again and again and make sure that we understand it clearly. So, whether or not it is relevant to the class, but if you're already spending time and energy explaining this, so might as well.
That's the plan. So I'll save this paint file as well. What's the name? Actually, static route. Okay, guys, I'm done for the today. I can take the more as well, half an hour more. But the problem is that if I want to take the more, it will take a bounce over there, right? So let's make the leave for the today. Tomorrow, we'll do the like a conclusion for this guy, and then we'll jump to the next pattern. Okay.
Thank you very much,
On
sir.
the Friday, we can jump to the EIGRT protocol.
Wow,
Okay, I'll see you tomorrow, guys. Bye bye. Have a great day.
Bye. Thank you.
Thank you.
Thank you.
Good night, sir.